And the craziest part is, Netflix uses their feature store to serve up billions of personalized recommendations every single day. I mean, think about that scale. Billions.
Billions? Okay, that's a lot of features. But I still think most people hear feature store and immediately glaze over. It sounds like just another buzzword.
Exactly. And that's a problem because if your ML platform is struggling with data consistency or slow feature retrieval, you're likely missing a crucial piece, a well-designed feature store. It's not just a nice to have, it's becoming a necessity, especially as models get more complex and data volumes explode.
So, what breaks if you don't have one? Is it just slower training, or are we talking about actual production failures?
Oh, it's way beyond just slow training. Imagine your Uber trying to predict ETA. Without a feature store, you're constantly recomputing features like average trip time in the last hour directly from raw data every time a user requests an ETA. That's a huge computational burden, and it leads to latency spikes, inaccurate predictions, and ultimately a frustrating user experience. Worse, you might have different teams computing the same features slightly differently, leading to model drift and inconsistent predictions.
Okay, I see. So it's about both performance and consistency. You're pre-computing and storing these features so you can access them quickly and reliably, right?
Precisely. Think of it like this. A feature store is like a shared memory layer for your entire ML platform. Everyone, training pipelines, inference services, even ad hoc analysis can access the same consistent, up-to-date features.
Shared memory layer. I like that analogy. So let's break down how this shared memory layer actually works. What are the core architectural components?
First, you've got the ingestion pipeline. This is where you define how to extract features from your raw data sources, databases, data lakes, streaming platforms. Think of it as the factory that takes in raw materials and produces pre-computed features.
And this pipeline needs to be idempotent, right? So that if it fails and retries, you don't end up with duplicate features.
Absolutely. Idempotency is crucial. You also need versioning to track changes to your feature definitions over time. Now here's where it gets interesting. The feature store typically has two layers of storage, an online store and an offline store.
Okay, online and offline. What's the difference?
The offline store is usually a data warehouse or data lake, something like Snowflake or Databricks. It's designed for large-scale batch processing and historical analysis. It's where you store all your features, going back in time for training and backtesting.
Makes sense. So that's where you train your models. But what about the online store?
The online store is a low-latency database, often an in-memory key-value store like Redis or Cassandra. It's designed for serving features in real time during inference. When your model needs to make a prediction, it fetches the relevant features from the online store, which returns them in milliseconds.
Milliseconds. That's a huge difference compared to recomputing from scratch. But how do you keep the online and offline stores consistent? That seems like a tricky synchronization problem.
That's a great question. That's where the feature store shines. The ingestion pipeline is responsible for writing features to both the online and offline stores, ensuring consistency. Feature stores often use change data capture, or CDC, to propagate updates from the offline store to the online store.
So CDC is listening for changes in the offline store and then pushing those changes to the online store, like a giant sync button?
Exactly, and that's critical for preventing what we talked about earlier, model drift. You need to ensure that the features your model sees during training are the same as the features it sees during inference.
Okay, this is starting to make a lot more sense. So we've got ingestion, online store, offline store, and a synchronization mechanism. What about feature governance? How does the feature store help with that?
Feature governance is another key benefit. A feature store provides a central catalog of all your features, along with their metadata, who created them, what data sources they're derived from, how they're calculated, and who's using them.
So it's like a data dictionary for features.
Precisely. This makes it much easier to discover, reuse, and manage features across different teams and projects. Think about a company like Meta, with hundreds of different ML models running across Facebook, Instagram, and WhatsApp. Without a central feature store, it would be a nightmare to keep track of all those features and ensure they're being used consistently.
Okay, Meta definitely needs this. But what about smaller companies? Is a feature store overkill for a startup with just a few ML models?
That's a fair point. For very small teams, it might be overkill to build a full-blown feature store from scratch, but even small teams should be thinking about feature engineering best practices, defining features consistently, tracking their lineage, and avoiding redundant computations. You can start with simpler solutions, like storing pre-computed features in a shared database or using a feature engineering library like Feast.
Feast. I've heard of that. Is that like a feature store light option?
You could think of it that way, yes. It provides a lot of the core functionality of a feature store, feature definition, storage, retrieval, but it's designed to be easier to set up and use for smaller teams.
So, for a startup, maybe start with Feast and then migrate to a more robust solution as your ML platform grows.
That's a very common pattern. Now here's where it gets interesting. Most engineers think of feature stores as purely a technical solution. They focus on the performance and scalability aspects. But the real power of a feature store lies in its ability to democratize access to features and empower data scientists.
Democratize access? What do you mean?
Think about it. Without a feature store, data scientists spend a huge amount of time just finding and preparing data. They're constantly reinventing the wheel, writing the same feature engineering code over and over again.
Ah, yes, I've definitely seen that happen.
A feature store eliminates that wasted effort. It provides a central repository of pre-built, validated features that data scientists can easily discover and reuse. This frees them up to focus on what they do best, building and tuning models.
So, it's not just about speed and consistency, it's about making data scientists more productive.
Exactly. It's about enabling them to iterate faster, experiment more, and ultimately build better models. Think about a company like OpenAI. They're constantly experimenting with new models and architectures. A feature store allows them to quickly prototype and evaluate new ideas without getting bogged down in data preparation.
That makes sense. So, it's an enabler for innovation. Okay, this has been a really helpful deep dive. So, what are some practical takeaways? What should a software engineer do differently after listening to this?
First, start thinking about your features as products. Just like any other piece of software, features need to be well-defined, well-documented, and well-maintained. Treat your feature engineering code with the same rigor you would any other production code.
Okay, features as products. I like that. What's next?
Second, start tracking feature lineage. Know where your features come from, how they're calculated, and who's using them. This is crucial for debugging issues, understanding model behavior, and ensuring data governance. Think of it as version control for your features.
Version control for features. Got it. And
Finally, start small. Don't try to build a full-blown feature store overnight. Start with identifying your most commonly used features and building a simple pipeline to pre-compute and store them. Iterate from there. Think of it as crawl, walk, run. Start with the low-hanging fruit and gradually expand your feature store as your needs evolve.
crawl, walk, run. That's a good way to think about it. So, to recap, treat features as products, track feature lineage, and start small. Any closing thoughts?
Absolutely. Remember, your ML models are only as good as the features you feed them. A feature store is the foundation for building a robust, scalable, and reliable ML platform. It's the secret ingredient that separates the amateur ML projects from the world-class ones.